Okay, when I was looking over the homework in WebAssign, I was surprised to see the question about the parabolas, including an issue about the focal diameter. And that was not in my notes. So I've added it to my notes. Right. We'll go through it. It's going to be something that you're going to have to answer in the WebAssign. All right. So it says the line segment, and I'll go to the whiteboard later to show you what this is visually. The line segment that passes through the focus and is parallel to the directrix is called the lactus rectum, also called the focal diameter. In WebAssign, they say focal diameter. The endpoints of the focal diameter lie on the curve. By definition, the distance d from the focus to any point P on the parabola is equal to the distance from P to the directrix. So let's say, I realize for some students, that's just way too many words, and comprehend it might be difficult as well. There is a footnote over here I want to point out. You can click on these things, it'll bring you right to the footnote. And what does it say? It can be shown that the focal diameter is actually 4 times the absolute value of P. All right. So I'm gonna go to a different share, and I'm gonna reread it to you. All right, different share. And just give me a moment to do so. And this is what I would recommend you do when you're reading as well, to try to understand what you've read. And certainly if a visual is given to you, the visual may be helpful. And a visual has been given to me. All right. So let's talk about it. All right. So the first thing I want to talk about, just in reading it, I want to talk about the first thing they say. They say the line segment that passes through the focus and parallel to the directrix. Okay. So let me draw that line in for you. There's a line parallel to the directrix. I want to point out this is the directrix right over here. It says it goes through the focus. This is the focus over here, and it's parallel. So what would that look like if I drew that in? You know, I'll do the best job that I can do. Okay. In WebAssign, they're going to talk about this thing as being a line that passes through the focus and parallel directrix called the lactus rectum, also the focal diameter. And someone says, where get a diameter of that guy over here? Well, this is where it gets a little bit tricky. I want to point out the diameter they're talking about is this distance here. All right, we want to get that distance over there. This distance here, the distance between this point and this point, is going to be called the focal diameter. It's a distance. Now I'm looking at this guy over here, and I'll be honest with you, if the picture's accurately drawn, I think I can get that. And what I mean by that is I'll just talk about, you know, the distance between the focus. This is the focus. And this is a point in the parabola. What's that point over there? Well, let's take a look at it. It looks like 5,1. And what's the focus going to be? It looks like, whoops, sorry about that. It looks like it's, I don't know, it looks like 1, -1. And what's a distance over here? And again, I'm just talking about this distance here. All right. Well, what distance over there? If looking at it, it looks like 4 units. So what's this entire distance over here? It's going to be 8 units. So let me write this down for you. The focal diameter for this parabola is 8 units. Right? Focal diameter is 8. All right. Certainly someone could say, do I have to do that each time they ask me that question? Not really. What are you doing over here? You should have some concepts down. For example, you should know that this here is length P. When I say that, P could be positive or negative. So I'm going to say absolute value of P. And the length here is also the absolute value of P. Right? So then the question becomes is, what's this distance? All right, that distance is going to be 2 times P. All right. 2 times, when I say 2 times the absolute value of P, I'm sorry. Well, if that's true, what's this guy's distance? Well, the defining feature of a parabola is that these are going to be equal distance. So this guy over here is also 2 times the absolute value of P. So what's the entire distance going to be? 4 times the absolute value of P. So what does it say in the footnote? It says that it can be shown, and again, we'd like you to read this. I know it's difficult reading through that stuff. It can be shown that it's 4 times the absolute value of P. So the focal diameter, and we just showed by this example over here, is actually just 4 times the absolute value of P. Fairly easy to do. What do you need? You need to know what P is, take its absolute value, and multiply it by 4 to get the focal diameter. All right, that's a defining feature of the conic section called parabola. All right, so I hope that clarifies some of the issues. I can't say this enough times. So a lot of times, what you're going to do, especially in most university educations, not everything is mentioned in lecture. Sometimes the instructor just simply forgets to mention something, or they're not looking at your homework, which is probably more typical, and they don't know what's being asked in the homework. All right. And the graders, and typically in university, whether it's going to be WebAssign or a graduate assistant, generally may not know what the questions are either. They're just simply, grading some of the questions, not all of them, of course, and they may not be aware of it. So I'm going to claim over here what you should be doing when you come across a question that's not familiar is, well, if you have a book, read the book. I do recommend that. Now, if you're not, reading books at this stage of your careers, I would say go to the internet and just type in focal diameter for a parabola, and you should get a ton of articles on it. And hopefully those articles will make sense to you. All right. Again, in WebAssign, they're going to ask for focal diameter. Thank you.